Good morning, everybody. Welcome to the Turfgrass Epistemology YouTube and podcast, where we are on a constant journey trying to answer the question, how do we know what we know about turfgrass? Thank you for joining me. My name is Travis Shaddix. I am a past lots of things. Past professor, past turf manager, past fertilizer salesman, all these things. So we are going to be going over a ridiculously difficult paper to understand, but very important. So I'm going to do my best to not screw this up. Hey, Lush. Hey, Gray. Thanks for joining me again. So we're going to be going over a soil test calibration during establishment. Fall is obviously here, it's coming up, and a lot of fertilizer is going to go down. And so I wanted to start with a paper today that a lot of other papers reference. So we're going to go over that today. The remainder of the week, we're going to go over, so tomorrow, we're going to go over a paper on I think it's cool season establishment, I believe. I don't really recall. It's either cool season or warm season establishment. So the fertilizer required or needed during establishment. So we're going to be going over that tomorrow. Maybe a 2-episode paper. Yeah, maybe. Honestly, this paper is so difficult to understand. I even question why I'm even doing it. It's not easy. So if you're looking to see my limits, Travis Shaddix's limits on his knowledge, you found it right here on this paper. It's challenging to understand. I'm going to go over it and explain why I've had such difficulty with this paper. But yeah, it's a challenge. So I'm going to explain exactly why I think it is a challenge today, guys. Here's the paper. It's called Soil Test Calibration for Establishment of Turfgrass Monostands by Turner and Waddington, 1983. Turner and Waddington, as you may know, are no doubt very respected and well-accomplished scientists in the field of turfgrass. Their 83 paper is important. A lot of papers after this reference back to this paper. And we're gonna do our best. I'm gonna do my best to not mess this up. But as we start off, as in each day we're here, we're going to do our due diligence and explain how you would even find it. Google Scholar, which I don't even know when it came around, but I never used Google Scholar until the last 5 or 10 years. But it's actually a really good resource. Turfgrass information file, as you've heard me say before, is another resource I use to find information on various turfgrass topics. So feel free to use that as well. I'm sure this paper would pop up in Turfgrass information file as well. But if you didn't know anything about the title of the paper, obviously, if you're searching for a topic, you're not going to know the title of the paper. So you would type in some words that are based on the area you're trying to research. So if you're going out and you're applying or you're establishing tall fescue, which is right outside my window here in Lexington, where I'm doing little sections of my own lawn, and you wanted to know, hey, how much fertilizer do I need to apply? I've heard phosphorus should be applied, and phosphorus increases establishment, or potassium increases establishment, or whatever, nitrogen, whatever. I need to know if that's true or not. How would you even go find that information? So you type in whatever I don't know what you type in. What I would type in is, fertilizer for turfgrass establishment, or nutrients. Let's see what happens if I type in nutrients during turfgrass establishment, something along those lines. See what happens. Effects. I'm looking for soil test calibration. See if it even pops up. Effects of compost. Actually, I think this might be the one we're talking about tomorrow. I can't remember. review. This was from UF people, I think. Biosolids, aluminum, effective water quality. So it doesn't pop up here. Turfgrass, Easton, Petrovic. So don't see it popping up there. So let's do soil testing for turfgrass establishment. Maybe that's, here you go. Soil test calibrations for establishment of turfgrass monostand. Assessing soil carbon sequestration. I'm just reading some titles I'm finding on Google Scholar. Looney saying, I bet they'll try to sell you kelp with that search. Actually, it's funny you say that, Looney, because I'm trying to get an author of a paper to come on and actually discuss his paper with me, and it has to do with a turfgrass establishment. And on there, one of the treatments he included was sea kelp extract. And so I don't know if I'm going to be able to get him on in the next week or two. He has a pretty busy schedule, but I can go over the paper. But I thought, since I finally figured out how to get someone on live and not mess everything up, that I would just invite the author on to come and have a conversation with me about their own paper. So I'll see what I can do about that. To get everybody's schedules lined up is kind of difficult, but so anyway, this is the paper: soil test calibration for establishment of turfgrass monostands. So I just click on Google Scholar link and it brings me to the paper that was published in the Soil Science Society of America journal. I haven't really gone over this, but if you are a member of the American Society of Agronomy, you probably already know this, but there's really 5 journals in the ASA that are four, but let's just talk about 4 at the top of the ASA that we aspire to publish in, and most turfgrass scientists and soil scientists generally will publish in. They're Crop Science, Soil Science Society of America journal, which is this one, Agronomy journal, and then Journal of Environmental Quality, JEQ. So those are the 4 journals. So any articles in those journals are generally seen as quite good. The value of those papers is substantially higher than the value of papers in other journals that maybe I'll go into ranking journals. Anyway, so the soil test calibration of established monostands is in Soil Science Society of America journal, SSAJ. So here we go. So the abstract, you can read this for free. You don't have to pay anything. If you want the whole article, you can download it as a member of the ASA or go to your library. But you can get some basic information for free. And that is, little information is currently available relating to fertilization and soil fertility to turfgrass establishment response. So right there from the beginning, he's saying there's not a lot of information about nutrient requirements during turfgrass establishment. He goes on and talks about the study, the materials and methods, talks about the initial turfgrass or soil test levels, phosphorus addition. Here we go. Phosphorus additions to the soil had the most important effect on turfgrass establishment. So the phosphorus additions are what they found in this study to be the most influential. The initial soil test level was 60 kilograms per hectare. The initial soil level of 60 kilograms per hectare was not. Oh, there's a missing word there. The initial soil level of 60 kilograms per hectare was not sufficient for rapid turfgrass establishment. So we're going to differentiate between what he's saying. Let's be very specific. He's talking about rapid turfgrass establishment. So that's the metric that he's saying that level was not sufficient for. The author will state in here, if rapid turfgrass establishment is not particularly of interest to you, then 60 is probably good enough. Okay, so this is where I always have a challenge trying to communicate to people, especially with soil tests, is that the metric used, let's say turf quality, or in this case, let's say rapid turfgrass establishment, is not the same for everybody. It's a subjective metric. It's based upon whatever the observer desires. So, like I've said before, if my neighbor thinks her lawn is good enough for her, then it's good enough for her. It doesn't matter if it's good enough for me. So, if you're going to set a metric and say you should apply this amount of phosphorus, based upon what? Based upon rapid turfgrass establishment. Okay, well, what if I don't want rapid turfgrass establishment? I personally don't want rapid turfgrass establishment. You can go look outside my front lawn right now. It's been 3 weeks and the tall fescue is growing fine. For me, I applied a little bit of nitrogen the other day. It was speeded up a little bit. My neighbor across the street who has the exact same turf that I seeded might want more rapid turfgrass establishment. So he might need to apply a little bit more nitrogen or a little bit more phosphorus or whatever. So because the metric used is presupposing that everybody's going to want that, everybody's going to want the same turfgrass acceptable limit or the same rapid turfgrass establishment limit or whatever the case is. They're presupposing that's what everybody wants. Then this is how much you should apply. And that's the reason I think a lot of these are flawed. Like, let me give you an example. Find me one farmer anywhere who's not an insurance farmer, okay? A legitimate, farmer who's farming for to grow food and to make a profit. Find me one farmer who will say the following and be honest about it. I know what you're saying is going to make me more money, but I don't really want to make more money. What farmer is going to say that? Soil tests in agriculture are designed to increase profits, period. Those farmers aren't necessarily growing corn and growing wheat and growing sorghum and all these things. They're growing money. They're there to make a profit. And soil tests are there to predict the amount of nutrient required to increase profitability. Okay. And that's fine. This is capitalism. Okay. We're all about that. So they're there. They know, hey, it's going to cost me whatever, $50 an acre to apply X nutrient. For that extra $50 an acre, I'm going to make back another 100 or whatever the number is. So I know the probability that my money return is going to be greater is X, whatever it is. That's a great metric. It's based upon profit. In turf, we don't, consistently have the same desired metric. Okay, and that's one reason why I have such an issue sometimes with soil testing, because it's presupposing that everybody agrees we want to make the most money as we can. Well, we don't do that in turf, okay, unless you're in sod production. That's different. That's more agriculture. Okay, so right here, the initial soil level of 60 kilograms was not sufficient for rapid turfgrass establishment. If you care about rapid turfgrass establishment, then that matters to you. If you don't care about rapid turfgrass establishment and you're okay with just an average or slow, mediocre, establishment, which is me, I don't really care about it too much. I just want it to grow in before the season is over. That's fine with me. Then that 60 kilograms is probably enough, as the author will state clearly. So be mindful of that, okay? Seedbed P applications, and this is where this paper is going to go off in left field, and I hope I don't screw it up. Seedbed P applications in the range of 1.6 to 4 kilograms of phosphorus per R. What is an R? A-R-E. Now, I've been doing this for a long time. And for the most part, people use the same metrics, SI units, which is a French acronym for scientific units. And that is hectare, that is kilograms, that is, units that you've seen me talk about before. R is also a metric unit. I don't know if it's an SI unit, but it's not a common unit. Okay, it's not a common measurement in R. Okay, what is an R? An R is 100 square meters, whereas a hectare is 10,000 square meters. So it's a very unusual metric to use. 1.6 kilograms per 100 square meters. And so I'm going to do my best to get all this lined up, but I believe if I make a mistake, please don't crucify me. So the P applications in the range of 1.6 to 4 kilograms of phosphorus per 100 square meters, which is very high, resulted in soil P levels of approximately 110 to 180 kilograms per hectare. So 180 kilograms per hectare, the best of my calculations, they didn't give me the depth that they took the soil test from, so I'm assuming that they took it from 6 inches, is about 80 parts per million phosphorus. proved to be the most satisfactory in promoting rapid establishment as determined by turfgrass chemical composition, ground cover, and quality. Okay, so they're saying that somewhere between 80, and I don't know what 110 is. It's probably, I can't remember what that is. It's probably 70 or 60, I don't know, 60 or 70. I can't remember. I have to do the math. But no more than 80 parts per million. This 180 is actually 80 parts per million phosphorus. And somebody do the math and realizes that I'm doing my math wrong. That's fine. Just correct me. Is the most satisfactory. So that's quite a bit higher than what you might be familiar with, like the lower parts, the lower phosphorus concentrations. Okay, so we're going to go into that a little bit more. Differences due to P tended to diminish with time, indicating that where rapid establishment is not critical, the 60 kilograms per hectare of P in this soil may be sufficient to obtain satisfactory stands of the species investigated. So that's what I said earlier. They say if you don't want rapid establishment, it's probably enough. You don't need to apply anything more than that, or need to have any more phosphorus than that if you don't desire rapid establishment. He talks about pH, K, and da-da-da. So we'll just go through this. This is just the abstract mining. We haven't even got to the article yet. Potassium applications either reduced or had no effect on initial ground cover and had little effect on turfgrass quality. Now, where have we read that before? Potassium applications had no effect on turfgrass quality, or it resulted in a reduction in turfgrass quality. Okay? Keep that in mind the next time you're applying potassium. I'm not saying that would happen in your case. This is just one paper. Okay, remember, we're just talking about the boundaries, what we found within the boundaries of this paper. But when we see one paper talk about potassium and another paper say it doesn't do much, and another paper doesn't say it doesn't do much, our confidence begins to grow about potentially reducing or eliminating potassium unless there is a turfgrass deficiency in potassium that is confirmed potentially with the soil test. Okay. So I'm not saying to go out and do that, okay? I'm just simply saying that we see numerous examples in the literature where potassium's not doing much. And in this specific example, they actually showed it reduced the ground cover and had little effect on turfgrass quality, okay? Okay, so let's get into it. That's the abstract that you can actually go read for free, all right? If you want to get into the article itself, we're going to get into it, and we'll see how it goes. I'm not really convinced I'm going to be able to do this without screwing it up. Yeah, so Gray Fox, if we used that high a rate of P, aren't we likely creating an environmental problem? So I'm going to get to that in just a second. Okay. The word in your question that's important is likely. Okay. Yes, you are potentially do that. We're going to get into that. Okay, soil test calibrations for establishment of turfgrass monostands. The introduction was basically what I mentioned. There's not a lot of information known on it. The objectives of the study were to relate PK and limestone seedbed applications to the establishment response of monostands on 3 cool season turfgrass species. So they're going to measure the influence of phosphorus, of potassium, and of limestone on the establishment of 3 cool season grasses, and to determine the optimum rates of PK and limestone seedbed applications for the conditions present. So the objective is very clear. I like the objective a lot. Lechelon says, you're killing me on the potassium. Well, if you're applying a lot of potassium, you may have a good I'm all for nutrients. I'm just saying, have a good reason. Have a justifiable reason why you're including it. And maybe we can talk about that sometime. What are your justifiable reasons? Maybe you do have a justifiable reason. Maybe you are in a location where it's needed. In this particular example, you're going to see there wasn't much going on, and I can show you some other papers where there was some benefit to applying it, but it's almost always on low K soils. Sandy, low-K soils is where you will sometimes see a response to potassium, but generally speaking, in most soils, potassium doesn't do much. There's probably just as many publications showing there's a disadvantage to applying potassium to the turf as there are publications showing there's an advantage. So, yeah, I mean, it can actually cause problems, particularly on POA greens. You know, there can be issues with excess potassium. Anyway, so we're going to get into the materials and methods. This experiment was conducted on this silt loam soil at University Park, Pennsylvania. So there, you know, right now we're in Pennsylvania. Soil tests in September 1979 prior to fertilizer treatment applications were pH of 5.7, 60 kilograms per hectare of phosphorus, which 60 kilograms per hectare of phosphorus is 25 parts per million. I'm assuming they took a 6-inch soil sample. I may be wrong on that. Somebody please correct me in the comments if you feel obliged to do that. 0.1, 0.7, and 4.3 centimoles phosphorus per charge per kilogram of potassium. That unit is very peculiar. Potassium, potassium, magnesium, and calcium. Okay. Cation exchange capacity was 8.4. Soil pH was determined using a 1-to-1 soil to water paste, and available soil nutrients were determined using the Bray. So those values I just mentioned to you were on the Bray, using the Bray extract. So you can't relate that exactly to Mehlich 3. I know some people would like to do that, but you can't just convert it over easily unless you have a correlation calibration done on that soil and you know the equation to do it. Normal ammonium acetate extractant was used for K, magnesium, and calcium. The Bray was used for phosphorus. The current soil test interpretation showed phosphorus as low and potassium as low medium. Recommended rates of PK and limestone were used for the center point treatment. Okay. Here's where it says 1R equals 100 square meters. I'm sure that exists in other literature. I've just never seen that. And it's very difficult to, it's not difficult, but it's, my brain is wired for kilograms per hectare and parts per million, and then switching it to pounds per acre. Kilograms per 100, so that's 1/10 of a hectare is trying to switch things around. It's not easy. So let's look at the rates they use. So that that was the seeding rates. Okay. That was a point. Okay. We don't really need to worry too much about that, but 3 studies were conducted with this experiment to provide treatment evaluations. I'm trying to get to the seed. Okay. Turfgrass species. So it's September 7th, barren Kentucky bluegrass, a chewing fescue, and perennial ryegrass were the 3 species of cool season grasses that they used. I'm not going to get into this a whole lot on the methodology, but I just want to point out something. I don't want to bore you to death with methodological jargon, but I just want to point out that the experimental design used was a 5x5x5 central composite rotatable design with PK and limestone treatment. So again, this design is, I'm not an agricultural statistician. The design's probably fine. I'm sure it is. I just almost never run into that design. And I never run into the unit of an R. Okay. It's difficult to work my way through this when I'm running into a design and I'm completely unfamiliar with. I'm running into a unit I'm completely unfamiliar with. And you'll see later on the statistics are based upon modeling. There's not any mean separations from one treatment to the next. So there's 3 things that are kind of working against me here, trying to figure out what happened and whether or not, what value we place in it and so forth. Okay. But just wanted to point that out, that the model for those grad students and whoever else is listening is a central composite rotatable design, which is very uncommon in turfgrass research. Okay, it might be. I'm sure it's perfectly fine. Okay, to use. I'm just saying it's uncommon. And then it says the PK and limestone from triple superphosphate, potassium chloride, and granular limestone were incorporated into the soil to a depth of 11 centimeters. So that's about 5 inches. in 1977. I thought I had in here the rates somewhere in here. I'm going to have the rates of what they used. Okay. The center point treatment combination was 4 kilograms of phosphorus per R. So you have to multiply that by 10. If I'm reading this correctly, you have to multiply this number here by 10 to get to kilograms per hectare. Okay. And so when you get to kilograms per hectare, to get to pounds per 1,000 square feet, I just go to the internet. In fact, let me do that. It's right here. So here's the internet. So it's 4 kilograms of phosphorus per R. So we have already done the conversions from 4 times 10. It's going to be, it's times 10. It's going to be 40. And you're going to put in, so it's pounds per 1,000 kilograms. So 10 times 4 is 40. And so that's in kilograms per hectare now. And we're going to go to pounds per 1,000 square feet. So you got, that's not that bad. You got 0.8 pounds per 1,000 square feet of phosphorus, the center point treatment combination. And then 7.6 of K, and then 61 kilograms of limestone, okay? For some reason, I thought that was different when I first read this paper, but that's what we're dealing with in terms of the center point combination of the phosphorus treatment. Man, it's going to be, I'm going to screw this up. I'm telling you guys, it's not easy to get through this. Okay. 1977 and 1978, the relative rates of turfgrass establishment were evaluated by estimating the turfgrass cover, percentage of soil surface covered by green vegetation. So that's how they measured cover. They just percentage of the soil covered by green vegetation. Periodic quality ratings on a 0 to 10. 0 is dead. 10 was the highest quality, were made following these initial ratings. Okay, so that's how they did the quality. So we know how they did the cover. We know how they did the quality. Recovery was evaluated by periodic visual quality ratings. Sod strength was measured. The bluegrass and fescue turf was measured on using a technique similar to that of this. The sod was clamped to a split platform, and the force required to tear the sod measured as force required to tear were slowly separated. So basically, they clamped them. They pulled the sod apart. And they measured the force required to pull the sod apart as a measure of sod strength. Very common method. And they measured some weeds during that time period as well. Okay. You can see I'm struggling with this. This is not easy, I'm telling you. Hey, Randy. 5 p.m. there. Okay. Well, I can't remember where you said you were. I think I said Bulgaria or something. I can't remember, on the other side of the planet. But thank you for joining us. I really appreciate everybody for joining me. It's a pleasure to have you guys here. Okay, so the before I get too far, the where was it in here? There was a model. Here's the treatments, the coded values and application for rates. They have the various treatments and rates and all these other things. What they did was they used modeling to create a three-dimensional graph, which is fine. But because three-dimensional graphs have an infinite number of points between 2 points, you can't measure all those directly. So you use a model to do that. It predicts what would occur from one point to the other and creates a three-dimensional model, which we're going to look at. But they show in here how they did each one of these. So when you see elemental leaf analysis response equations, all these equations are the equations that they used, I believe, to generate these graphs. So if you wanted to redo it, you know exactly how they did it. Lots and lots of equations in this document. So let's get to some of the results. So on bluegrass, phosphorus applications affected clipping yields on each sampling date through June 1978. And it shows the figures where he shows these. Figures 1A, 1B, and 1C. However, after this date, P no longer influenced top growth. Clipping yields increased linearly with applied phosphorus for these dates. Although the relative effect decreased with each successive sampling, indicating the greater importance of phosphorus in the early stages of seedling growth. So what he's saying here is that you saw a response early on from the phosphorus application and not so much later on. Okay. And that's, according to what they're saying in the results, is that indicates that there's greater importance and greater influence of the phosphorus early on in the seedling development. I think I'm within my boundaries to say that that's likely true in many cases as a result because of the lack of soil that the turfgrass is actually penetrated and harvesting nutrients from. You have one little root coming from the seedling, and that root only has the available nutrients that it encounters around that root. And once the roots spread out and the grass begins to grow and you have this, network of roots, then it can harvest more phosphorus from that soil. And because of that, especially as the deeper it goes and so forth and the wider it goes, the amount of phosphorus in the soil doesn't need to be quite as high because it's able to harvest more phosphorus from the soil because it has a greater root density, root mass, and all that stuff. But early on, it doesn't have that ability. So applications of phosphorus sometimes show a benefit early on. Okay, so that's what he found in bluegrass. Okay. Potassium applications only affected clipping yields after the June 27th sample. General clipping yields from June, greatest set. Okay. Limestone applications decreased clipping yields slightly where no potassium was applied and increased growth where potassium was applied, with the degree of increase greatest at the higher K rates. I'm going to show you a graph in a second that explains it a little bit more, but he's basically saying when you applied limestone and no potassium, there was a decrease in clipping yields. It required the addition of potassium to offset or balance off or whatever the influence of the application of the lime. Limestone applications also affected clipping yields on several other dates. Clipping yields for the May sampling date were decreased by limestone applications, again, which may have been due to reduced availability of the added or soil phosphorus due to a reaction with the added limestone. So let me explain that briefly. They're applying limestone, which is calcium carbonate, along with phosphorus and potassium. And when you do that, in some instances, the phosphorus loves everything in the soil. It binds with iron and calcium and basically anything. Any cation almost. It loves iron and loves calcium. So when you're applying limestone, which will eventually solubilize, calcium carbonate, which will eventually solubilize, and you're applying phosphorus with it, there's a potential that those calcium and phosphorus elements that you applied will bind with each other and render it unavailable or insoluble, I should say. So what he's saying is that there was possibly a negative effect from applying the limestone as a result of potentially binding the phosphorus and rendering it less available. And that's what he's saying. So let's go to chewing fescue. Let's tell you, we were on bluegrass, so let's look at the bluegrass graphs. I'm sorry for those guys who are just listening. I'll try to decipher what I'm talking about on these graphs if you're driving or listening. So this graph here, let's see if I did this yesterday with a little, what did I do? How can I do that here? Somehow I did, here we go. Okay, so what we're looking at on this graph is yield. It's a three-dimensional graph. So you're looking at a line graph. So you're looking at yield on the y-axis. Limestone applications are increasing on the first x-axis, and P applications are increasing on the second x-axis. And you'll see as they're increasing the limestone with no phosphorus, the yield is going down. Okay. When you're applying phosphorus with no limestone, the yield is going up. This graph, its yield's going up. And when you're applying phosphorus with that was without limestone. And when you're applying phosphorus with limestone, the yield's going up on this side. If I can do that, I don't know how I did that little thing on this side of the graph right here. So the yield's going up. So what this is saying is that the application of phosphorus increased the yield on this specific date with or without limestone. It was the absence of phosphorus with limestone that resulted in a decrease. So let's look at these are the two dates. Limestone with, these are just separate dates. So yield on these various dates. So this was in May of 78. In June of 78, you see a very different curve where you see the phosphorus having less of an impact. And even in September, look at the influence in September. So you went from May to June to September, and you see the influence of, this is potassium. So from May to June, you see the influence of phosphorus being a little less in June than it was in May. That's what he was saying, where the influence of phosphorus was more shown or more impactful early on, not so much later on. Okay. And with potassium, you see some increase. Even with limestone, you see some increase down here at this end of the graph, where you are applying 15.2 kilograms per R, which is, let's see what that is. 15, so that'd be times 10 would be 150. So 150 would be 3 pounds a K. Okay, so 3 pounds a K, you're seeing a little bit of a benefit even with lime. You're showing very little benefit without it, and you're showing very little benefit of the lime with the potassium, or without the potassium, sorry. So anyway, you can see how difficult this is to make your way through it. I mean, I don't claim to know a lot about this stuff, but I mean, I know some basic stuff about scientific literature, and man, it's not easy to get through this paper. Sorry for the authors. I don't mean to be disrespectful. They were obviously much more accomplished than I ever was, but yeah, it's challenging. Chewing's fescue. So look at the fescues. Top growth of chewing fescue was affected by fertility treatments on fewer occasions than bluegrass, which may indicate somewhat lower fertility requirements of the fescue. So, yeah, there you go, Randy. So R is 100. Oh, you weren't here at the early part of, 100 square meters and 1,000 square feet. Reason I highlight this on the chewing fescue is that whenever you see a sort of a unilateral soil test requirement saying this is what it should be, they're often not species specific. Okay, well they might have a different one from, say, Bermuda to bent or something. But within cool season grasses, what this is saying is that the chewing fescue was affected by fertility treatments on fewer occasions, which may indicate somewhat lower fertility requirements for this fescue, as opposed to the bluegrass, which was right up here. So again, that's another piece of information that I think should be relevant when you're trying to decipher soil test information. Well, what turf was it taken on? You're going to put that on your soil test submission form. I'm using bluegrass or whatever. I'm using fescue. But I don't have any knowledge of the degree to which they've correlated and calibrated these values on these different grasses. I suspect it's very little that they have. Okay. I suspect it's very little correlations and calibration studies have been done. They're probably just using one number for all grass. If you're lucky, maybe they're using one number for cools and one number for warm season, maybe. But if you don't know that, there's differences among cool season grasses in terms of their soil test needs, soil nutrient needs, and you say, you should be applying this much phosphorus. Well, this is saying that the chewing fescue doesn't need that much relative to bluegrass. Just another piece of information that I think would be relevant when you're aligning your confidence with what that soil test value means or says to you. That's one reason why I don't have a lot of confidence in it. Phosphorus is one that I do have some confidence in, but you still need to know what species it's relevant for. Phosphorus applications affected clipping yields only on the first sampling date for chewing fescue, with yield increasing linearly with applied phosphorus. Potassium influenced clipping yields during 3 sampling periods, with yield increasing slightly with applied K. Limestone applications affected yields slightly during 2 sampling periods, with yields increasing linear. So before I go too any further, I just remembered, we're talking about the yields increasing, yields decreasing, phosphorus application increase. I'm not good enough in statistics to know this, but nowhere in this paper are there separations of means. In other words, they applied this rate and they applied that rate. And what's the difference between these rates in terms of the response difference when this rate was applied versus that rate was applied? There's no mean separations. Now, maybe when you're using these models, maybe a statistician would say, yeah, you can say those are different because the model allows for that. I don't know. But up in the statistical tables up here, it shows the model. It gives me the R² value, right? Oh, I didn't mean to highlight that. It gives me the R² values, calculated range of element, but it doesn't tell me anything about what the variation was, what the standard deviation was, or standard error was, or least significant difference, or and in the materials and methods, it doesn't state anywhere that this sort of mean separation was conducted. So it's just very foreign to me to see this increased, that increased, such and such was different, when I don't see any statistics showing me that. So again, that's one reason why this paper is quite challenging to work your way through. It's different when you see 2 numbers and they say, okay, this one's different than that, then you can have confidence. But on these graphs, there's an infinite number of p-values between 0 and 4 on this 3-dimensional graph. They modeled that, right? So 0 and 4 are different. Well, what about 0 and before that? Or 4 and 8? Or 8 and 0? I mean, I don't know, because it's not shown as a statistical separation in the way that I'm familiar with it. So, and again, I'm not saying it's wrong. I'm just saying I don't fully understand it. And I would need a statistician to come in here and tell me, yeah, this is valid. And, it's fine to say these are different because the model says it. I just haven't seen it. Anyway, let's go to ryegrass. The only date for which clipping yields were not affected by any fertilizer treatment was June 27, 78. Before this date, growth was influenced only by phosphorus and limestone applications. And the yield increased to about 4 to 6 kilograms per hour, about the 4 to 6 kilogram per hour range of applied phosphorus, with the greatest increase in yield per unit P applied occurring at the lower phosphorus rate, 2A. So if you go down here to 2A, you'll see this right here. So yield is on the y-axis, and we have increasing limestone and increasing phosphorus on the 2x-axis. And you'll see that as limestone went up, the yield slightly went down. As phosphorus was applied, the yield slightly went up. Okay, for ryegrass in June of 78, June 2nd of 78. June 13th of 78, you see the same sort of trend, but it's much greater yield. The yield is much more magnified during the June 13th date. Okay, so we see limestone by itself with no phosphorus actually reducing the growth rate, the yield. So to me, this seems to be a piece of evidence that I would refrain from applying just limestone. If you're just going to do that, you need to apply the phosphorus with it, or the potassium with it. June 25th and the September 20th, you can see the model predicts different things here, but in general, this is potassium. Now, so we're going potassium. You see the potassium slightly increases it by itself. The lime slightly increases it when at the high rate of potassium, and it has a less of an influence at the low rate of potassium. So that's how to read these graphs. Let's go to Bluegrass. I'm trying to get through this quickly here. And the reason I'm going over this is because so many other papers review this paper, or they talk about this paper. So I want to get it out of the way because there's much easier papers to understand than this one. Okay. Bluegrass. Phosphorus applications generally had the most important influence on bluegrass establishment. What did I have up here? Yeah, bluegrass here too. What did they change? Oh, we're going to ground cover, turfgrass quality. Okay. So now we're talking about ground cover, turfgrass quality, and sod strength. Phosphorus applications generally had the most important influence on bluegrass establishment. Rate of establishment as evaluated by percent ground cover was increased by phosphorus applications. Ground cover 5 weeks after seeding in the fall was about 24% less cover on 0 P plots than on plots receiving the high rate of P, 5 kilograms, figure 3A. We can go down to that. On both of these dates, potassium applications decreased ground cover. 5 weeks after seeding, 0K plots had 19% more cover than plots receiving 15 kilograms of potassium per hour. The next April, 0K plots had 20% greater ground cover than plots receiving the highest K rate. So here's the example I'm going to show you in figure 3B, where applying potassium reduced the ground cover. Although not measured in this experiment, soluble salt levels from the high rates of muriate of potash may have been sufficiently high to cause injury to some seedlings. That's completely speculation. That would not be allowed probably in today's review process, because he has no clue what happened. They didn't measure that. He's simply speculating that may have happened or may not have happened. We have no idea. So be aware of that when you see this. Some of the older literature, even today's literature, sometimes allows things like this in. But when the author is speculating, many times that's not allowed in today's publications within certain limits. I mean, you can speculate on plausibility, biological plausibilities, like in this case, he's speculating, okay? But you have to be real careful how that's done so that it's not misinterpreted as if this is what the authors are saying, why this happened. This is why this occurred. That's not why it occurred. We don't know why it occurred. It's just a supposition. It's just speculation is all that is. Okay. Generally, that's limited quite a lot in scientific literature. Speculation is fine, but it has its place. So 3A and B and C. So here you see predicted ground cover responses of Kentucky bluegrass to phosphorus and potassium of chewing fescue and perennial rye. So we got our chewing fescue and perennial ryegrass. Okay, fescue and rye. Here we go. So you'll see on the top, you'll see bluegrass. Well, this is bluegrass. So bluegrass on November 2nd and April 12th of 77 and 78. The cover percentage, here it is, potassium right here. Let me get the little highlighter. That potassium application going from 0 to 15 kilograms per hour, which I don't remember what that is. I'll have to look it up, is going down. Okay. And the same thing happened with this bluegrass, and you saw it in April. It's still going down. So the application of potassium in this case is reducing the percent cover at no phosphorus, and it's reducing the percent cover even at the high rate of phosphorus. Okay? So you won't see this all the time. I'm not saying this will occur when you apply potassium. But there's clearly good evidence here, and under the conditions similar to this study, where potassium is going to actually reduce your cover, reduce your percent cover. Okay? And you think you're applying it because you're going to increase the cover. Well, they're showing that it didn't do that. Okay? So this is another piece of example when I say there's probably just as many publications showing it's detrimental as it is beneficial, potassium, and this is one that's showing in this case is detrimental. Okay? So, this marketing, program or whatever it is to keep applying potassium, it's not supported a lot by science. I'll say that much. I mean, you need to see what the claim is and then go see if there's actually any evidence to support it, because if there is evidence to support it, there's probably evidence to refute it. And you kind of got to look at that within that context. You kind of balance all the evidence out, because I've never seen a response to potassium. I've seen a response to potassium sulfate. You've probably seen a response to potassium sulfate. But to potassium, I've never seen that. It's very difficult to see that. Okay. I'm not saying you're not seeing it. I'm just saying that is very unusual. And in this case, they're seeing it was detrimental. they've seen it's detrimental in, I believe it was Cornell. They've shown it's been detrimental on Poe and New Jersey. They've shown it's been detrimental to bent grass greens in Wisconsin. So to me, it's like, I would just cut it out until there's some good evidence to include it. And then when there's always, when there's good reasons to include it, then I would include it. But until then, I wouldn't really use it. It seems like a waste of money to me. But anyway, chewing fescues. Rate of establishment was influenced only by phosphorus applications, with 0P plots having a ground cover of 48% at 5 weeks versus 60 and 64% for plots receiving 4 and 8 kilograms of phosphorus R respectively, and that's at figure 3C. So that's right up here, 3C. So you'll see that this is kind of what I wanted to talk about, is that the percent cover as phosphorus goes up for fescue goes from 40% at 0 phosphorus to about, on this particular day, to about 60% at 8 in 77. And in 1978, it had at 0, it had about 65% cover, I guess, to maybe 70 or 80% cover. I guess they say it down there probably specifically, but that's around that number. And what I wanted to point that, and the same thing goes with rye. The ryegrass, between these 2 years, you go from 40-ish at 0 phosphorus to about 60 at 8 kilograms per R. And what I wanted to say was, if you desire that increased rate of whatever you're getting, another 10 or 20%, then by all means, go for it. I don't. It doesn't make any difference to me if I had 60% cover versus 75% cover. I suspect most people probably wouldn't even be able to determine that difference when you're just looking at it. But if you can and you want it to be greater, you'll need to apply the phosphorus according to these data. But if you don't care, don't apply it. Okay? And that's what, who was saying it earlier about the phosphorus creating an environmental problem? Gray was saying that, it doesn't create an environmental problem. Phosphorus does not create an environmental problem. It has the potential to create an environmental problem. That we got to start using that language, everybody. Phosphorus and nitrogen have the potential to create environmental risk, okay? Excess amounts of phosphorus, which by the way, before I forget, we're going to go over long-term phosphorus applications from biosolids in a paper coming up here, and I guess it'll be next week. And we're going to see how the application of phosphorus over 10 years influences the soil phosphorus following those applications, okay? Because excess applications of phosphorus, and what I mean by that is phosphorus being applied to plants that are growing on soils that are not deficient in phosphorus, that's excess phosphorus, or phosphorus being applied on low P soils in excess of what the recommendation would be to meet the plant demand, that's excess. That has the potential of creating environmental issues, okay? Microorganisms, microflora, microfauna in waterways that their growth are limited by phosphorus. Not all are, but those that are limited by phosphorus, their populations will explode, causing an ecological sort of imbalance, and you'll definitely see some long down the road problems with excess applications of phosphorus. So in this particular case, when I'm looking at these two ratings and I'm saying, well, applications of 8 kilograms per R are going to give me 75% cover versus not applying anything, not paying for it, not applying it is going to give me 65% cover. Well, I'm okay with that. It doesn't bother me. I save money and it's going to grow in anyway. It's just going to grow in a little slower and it costs me no money to do it. Then I'm okay with that. Okay. But if you're not, then, then you can apply more and you're going to get a little bit more cover. It's like speeding down the interstate. If the speed limit is 65, I have some limitations on my ability to go outside the law. I don't like doing that. So I drive 65. Okay. I have a buddy that'll drive 75, and we're driving from Miami to Gainesville, which is 4.5 hours, 5 hours. He's going to get there like 30 minutes before I do. Someone can run the math and figure it out. I don't care if I get there 30 minutes earlier. It doesn't matter to me. Okay, what are you going to do in that extra 30 minutes that's that important? Come on. So for me, I'd rather follow the law, get there when I get there, and I get there perfectly fine. For someone else, they want to get there really, really quick. Okay. Same thing with this. I'm going to get my lawn grown in, and it's going to be grown in. And it's going to look just fine. And I'm not going to apply a single ounce of phosphorus to it. But it's fine for me. I don't care. If somebody else wants to get it grown in that much faster, then this is showing you're going to probably need to do that in similar conditions of this study. Okay. But keep in mind, you don't have to. It's all dependent upon what your expectations are. And Looney, and Lush too, throwing it down. That's a great topic to discuss. People often think a biosolid is more environmentally friendly. There is a really good paper that I'm going to talk about next week that used biosolids for 10 consecutive years and then measured the phosphorus in the soil and then measured the phosphorus again 10 years later. Okay. And we're going to look at what long-term continuous applications of biosolids, how it influences the soil nutrient levels. And stay tuned for that one. We're going to go over. I'm not going to spill any beans here, but we're going to show what happened in that study very soon next week. Let me get through this. I'm already pushing an hour here. I got to get through this thing. Turfgrass quality was influenced in May by phosphorus applications, but was not affected by any fertility treatments in June, July, and August. In May, okay, we're talking about chewing fescue now in establishment. Sorry, I got to back up. I'm getting off track here. In May, the poorest turf quality was on 0P plots and was best for plots receiving phosphorus applications in the 4 to 6 kilogram per hectare range, per R range, although there was not a great difference among plots receiving phosphorus applications. Okay, so this is figure 3C. So we're still up here at 3C. So chewing fescues, this is what we're talking about up here. The fescue, where you see some differences, you see some increases for sure, but it's up to you, the observer, to determine whether or not you want to pay for that much money, whatever that is, to get an extra little edge on establishment. Okay. I'm not here to say you shouldn't have that, but I will say for me, saving money is more important than gaining an extra week or two of establishment, time or whatever. So, Lush, on a serious note, is there a need to apply the question in chat is there a need to apply phosphorus when the soil has ranges in 60 to 90 parts per million on a Mehlich 3 test? So I'm just going to try to stick to my guns here on this. I don't know the answer to that question. Okay. What I want to know is what the turf looks like, Lush. So if the turf is not exhibiting or showing signs of phosphorus deficiency, I care almost 0% about what that test says. I mean, there's something on there I might care about maybe. But if the turf is acceptable and it's not showing signs of phosphorus deficiency, then the soil test value is irrelevant. Well, okay, so for seed establishment, that's different. So if you're looking at for establishing seed, my adage or my criteria is the turfgrass acceptable? There is no turfgrass when you're establishing it by seed, right? The turf is literally growing nothing. It's 0 when you first seed it. So in that case, there may be some value to taking a soil test under my criteria because there's no turf. Okay, we don't know if it's growing. We know it's not growing at all. Okay, so when it comes to what should the Mehlich 3 phosphorus level be, that's kind of what this study is showing. And then the one we're going to go over tomorrow leads into that a little bit. That this is a Bray. It's not Mehlich. Okay, the one tomorrow, I can't remember what the soil test extractant was. We'll have to look at it tomorrow. I don't recall. I don't think it was Mehlich 3. But I can just give you my opinion. okay, which as we learned on, what was it, Monday, that my opinion is the lowest level. You should have the least amount of confidence in the hierarchy of evidence. You should have very little confidence in what I'm about to say because it's just my opinion. My opinion is that at a Mehlich 3 soil test of 60 parts per million, I'm going to assume you're going to use tall fescue. Let's just assume it's tall fescue. I'm going to not apply phosphorus in that case. Even now, I have no idea what my phosphorus levels are in my soil because I've never taken a soil test. I don't really care. Okay. And the grass is growing fine. If it wasn't growing fine, then I might take a soil test. But, I get it. If you're out there managing, 60 lawns, you can't necessarily have your eye on it all day long. I get that. So you kind of want to know what you're dealing with before you seed it. I appreciate that. I really wouldn't worry too much about phosphorus soil test, Mehlich 3 phosphorus soil test, even when seeding, until you get down pretty low. I do think there's I'll have to see if I can find this paper. I do think there is a paper that has a value in it, and I think it's actually relatively high. I think it was like in the 60s. I think I'll have to pull that up. I don't recall exactly, but it was much higher than like the 10 or 20 that I would normally run with. I'll look that up, Lush. Yeah, that's the purple level on the triangle. Yeah, don't take too much confidence in what I just said because it's, like I said, just my opinion. But I just don't get too warm and fuzzy on soil test reports unless there's a turf problem. I would probably still, honestly, Lush, I would probably still seed it unless you've had problems there in the past. I would probably just seed it. I don't know your seed. I don't know what grass you're planting, but I would probably seed it. Apply some nitrogen, either urea or ammonium sulfate. Keep that on the turf regularly until I saw a problem. I mean, I know it's hard to say that. I'm not running your business, so I don't know exactly if at that point it's too late and you got to go back and fix it. That might be what you're trying to prevent. I don't know, but I wouldn't worry about it at 60 to 90 parts per million phosphorus Mehlich 3. But that's just my opinion. I'll see if I can find a document that'll help reinforce that or refute it. Maybe I'm wrong. I will say this, that in newly seeded turf is very different than 5-year-old turf in terms of its nutrient needs on a soil test. Very, very different. You're dealing, it's equivalent of growing kids. When you first have a child and you take that child and you sit it in the incubator in the hospital, that's a very different nutrient requirement than you're dealing with an 18-year-old human being. It's hard to kill a healthy 18-year-old human. Okay, it ain't easy. Okay, and they're strong and they're matured. Little baby, you got to feed that thing constantly. You got to feed it every hour, every 2 hours. Sometimes it's liquid. You can't even feed it full, solid food. You got to wait until that child matures, and before it can finally get on its own diet and its own solid food, and now it's feeding itself and so forth. That's very much like plants are early on. When you seed that thing, it's got a tiny little root, very little ability to take up nutrients. And so you got to kind of make sure you're kind of got to baby it along. You got to make sure it has a little bit of water all the time, a little bit of nutrient, a little bit of nitrogen, a little bit of phosphorus. You got to be a little bit more careful with it early on. So during turfgrass establishment, those higher rates of phosphorus might be valid. You might need to keep those higher rates because of the inability of the seedling to harvest phosphorus out of the soil around a tiny little root. So I'll do some more digging around and see if I can find Kentucky Pinot Ryegrass. Okay, Kentucky Blue, yeah. And see if I can find you a better value, something that's been published on. For some reason, in the back of my mind, I'm pretty sure there's a value in the literature somewhere I think it's much higher than 20 for phosphorus on Mehlich 3, but I'll look it up. Thanks for the question. Oh, good. Last page. Okay, so perennial ryegrass establishment rate was related only to phosphorus applications. Okay. So perennial rye, they didn't have an influence of limestone or potassium. It was only from phosphorus. In 77, 5 weeks after seeding, and again in 78, 4 weeks after seeding, phosphorus rates higher than 4 kilograms per hour caused little further increase in ground cover, figure 3D. So basically they're saying the low level of phosphorus, which, let's do this again, 4 kilograms per hour. So that's, oh man, it's killing me. Is 0.8 pounds of phosphorus per 1,000 square feet, if my math is correct. And again, they tilled that into the soil in the top 5 inches, but at the low rate of phosphorus, they saw the maximum benefit. At higher than that, they didn't see anything. So keep that in mind. Let's get to the conclusions and get out of here before I torture myself any further on this paper. It's really hard. All right, the results indicate for all 3 turfgrass species that an initial soil level of 60 kilograms per hectare, which remember 60 kilograms per hectare is 25 parts per million of bray. Okay, 25 parts per million of bray was not sufficient for rapid establishment on the Hagerstown, I don't know how they pronounce that up there, Hagerstown silt loam. Seedbed applications in the range of 1.6 to 4 kilograms per R. So remember, 1.6 is, 1.6 would be 16. So 0.3 to 0.8 pounds of phosphorus per 1,000 proved to be most satisfactory in promoting rapid establishment. I really hope those rates are right that I'm doing the conversion on, because if I'm wrong, I'm screwing this whole thing up. I don't want to give you guys the wrong information. These applications subsequently resulted in soil P levels of approximately 110 to 180 kilograms per hectare, which, you remember, 180 kilograms per hectare is around 80 parts per million. Bray. However, when rapid establishment is not critical, so they're talking to me. When the authors say when rapid establishment is not critical, in other words, when you're driving from Miami to Atlanta and getting there quickly is not your priority, okay, the initial soil P level of 60 kilograms per hectare may be sufficient to obtain satisfactory standard Kentucky bluegrass. Okay, so you're dealing with 25 parts per million relative to 80. So they're saying, to answer your question earlier, Lush, is that was 60 or 80 good enough? Well, whether it's Malick 3 or Malick or Bray, they're saying, and I think this is somewhat translatable or transferable, and that is, if you care about rapid establishment, you probably need to go with a little bit higher phosphorus in your soil. But if you don't care, then the lower rates are probably fine. The lower concentrations in the soil are probably fine. Okay, so again, you have to ask yourself as the observer, what is your priority? We talked about that a little bit in the last video. Let's see. Okay, so last 2 or 3 things. Percent ground cover 5 weeks after. And so he says data obtained supporting these conclusions include 1, the percent ground cover 5 weeks after the 1977 fall seeding, and also the following April increased up to approximately 4 kilograms kilograms, or so 0.8 pounds of phosphorus per 1,000, which with little additional increase in ground cover occurring at the higher phosphorus rates. The greatest increase per unit P occurred between 0 and 1.6. So again, 0 and 0.3 pounds per 1,000. Okay, turfgrass quality, primarily due to density differences, continued to be affected by phosphorus applications through June, May, and July 1978 on bluegrass, fescue, and ryegrass. Quality generally improved up to approximately the 0.8 pounds of phosphorus rate, I guess, if I'm reading that right. Yeah, with little additional benefit occurring at higher rates. So what they're saying is there was a benefit up to a certain point, but after that point, there was no longer any benefit. There's no point in continuing to apply more. Okay, clipping yields were increased by phosphorus primarily in the earliest stages of establishment. The clipping yields of bluegrass, chewing fescues, and perennial ryegrass were not substantially affected by P after June, May, and July. So again, they're just saying that the majority of the benefit occurred early on. Okay, it didn't really transfer to later establishment phases. So I don't know, and I don't know how much I would, bank on. These are the rates you need to apply from this paper. These are the rates you need to apply, and this is what's going to happen. If you don't apply it, do apply it. What I would say is that there seems to be, whether it's 0 or 4 or 8 kilogram, whatever the rates were. the take-home message that I took, or the most important information that I took from this, is that there is good information in this paper showing that the influence of phosphorus was greatest early on in the first several weeks of establishment, and it waned after. As the turf established, it decreased. Okay, and from that concept was born my master's degree, where I'll show that, I guess some point. We applied almost no nutrient early on when the turfgrass had very little establishment. And then as the turfgrass established, as it was establishing, as more and more turfgrass was being produced, we applied more and more nutrient, nitrogen and phosphorus. Okay. So that was more of a progressive fertilizer application. We were trying to apply the nutrient relative to the amount of turfgrass that was on the plot. Being like you're applying very little food, or you're feeding your child, your baby, very little food compared to when he's 16, 17, 18 years old. They're eating you out of house and home at that stage. So the same concept was for turf, and that's what I did on my master's degree, and that's what we showed. I'll show that at some point, where you're applying very little nutrient early on, applying more nutrient later on, as opposed to applying the same amount of high food the whole time. We saw the same exact establishment rate. There was no disadvantage to applying less nutrients as long as you did it in a progressive fashion. So we'll show that. Okay, last thing, response of the turfgrass species was similar. However, the magnitude and duration of ground cover and quality response by the chewing fescues was less than the other two species. Thus, soil fertility levels may be less critical for chewing fescue than for Kentucky bluegrass or perennial ryegrass. So I'm glad they put that in at the end. I know I've kind of roughed up this paper a little bit because of the way in which it was conducted, and very peculiar sort of units and strange statistics, or lack of statistics. I know I beat it up a lot. I didn't mean it that way, but it's just very difficult to work my way through this when you don't see things as clearly as you're used to seeing it. But the last paragraph is critical, and that last sentence: soil fertility levels may be less critical for fescue than for Kentucky bluegrass or perennial rye. So again, I mean, we can't do soil testing on every conceivable combination of soil and tissue and nutrient and extractant. It's practically not possible, okay? But that doesn't stop agriculture from continuing to work on it. They continually update their, potassium recommendations for soybeans. They're continuing doing calibrations and correlations on soils in South Dakota and Nebraska. They're working on it. We're not in turfgrass. So just because there's a lot of work out there and it seems insurmountable doesn't mean we shouldn't continue to work. We need to be working on it, because this right here was printed 40 years ago, and it's saying right here that soil fertility levels are different for these grasses. But I doubt seriously if we have anywhere near the precision in our soil test recommendations to differentiate between these two species, between these three species. Okay, we're just giving one recommendation. Okay. And that's it. We're just saying this is what you should be applying. This is what the soil test level should be, and this is what you should be applying. Well, what if I have chewing fescue? I don't need anywhere near, according to this paper, I don't need anywhere near the nutrient level as I do if I have Kentucky bluegrass or perennial ryegrass. But I'm getting the same recommendation. I'm getting the same interpretation on the soil test. Okay, so I'm glad they put that in, because it's true in my opinion. I'm convinced that is the case. If you're dealing with, Bermuda grass compared to dealing with bent grass, it's kind of obvious. They're two different. You're dealing with two different species. It's obvious that you can't really compare these two in terms of their soil test nutrient levels. Okay, but they're saying even within cool season grasses, the nutrient levels differ. The soil test nutrient levels will differ. Okay, so just be aware of that when you're placing confidence in the soil test recommendations and interpretations. I as you've heard me say before, I'd be very careful with that. Okay, I wouldn't put a lot of confidence in those soil test interpretations and recommendations unless you're aware of how those were generated. If you know how they're generated, then the confidence level can go up quite a bit. But that's all I got for today. So tomorrow we'll be going over a much easier paper. I promise. I wanted to get this one out of the way because it's just it's a very important paper. I mean, it's just challenging to get through. And so I'm like, let me knock that one out and get it out. And we can go into a little bit more specific papers, a little easier to understand. And we can move on from there. So tomorrow will be another paper, much easier than this one to interpret, about nutrition during establishment. And I have some papers lined up for next week already. I'm trying to get another author on, and probably will be a while. His paper is on fall fertility as well, but I'm not real sure if we can line up our schedules to where I can get him to come on and talk about it. But if I can, I'll let you know, and we'll see how that goes. But until then, guys, I really appreciate everybody showing up. Thanks for all the comments. Don't forget to like and subscribe if you appreciate what we're doing. I like the back and forth. Apparently I'm supposed to ask people to like my videos, and I have no idea why. But anyway, appreciate everybody coming by today, spending some time with me. I'll be back tomorrow, same time, 10 o'clock tomorrow morning, and we'll talk about some more nutrient stuff for fall fertility. Appreciate everybody coming by. See you tomorrow. Bye.